Welcome to the EPOS Data Portal training event. My name is Jan Michalek. I work at the University of Bergen, and together with Harald Nedrebo, we will introduce the EPOS Data Portal and the basic functionalities. Here is the agenda. We will have 15 minutes introduction of the EPOS ecosystem, then demonstration of the EPOS Data Portal given by Harald, then the hands-on training session for 40 minutes where you will have time to go through the scientific use case through an online form. At the end, we will have a time for a walkthrough to show how the execution of the task could be done. And also we'll have 10 minutes for discussion. The open science is not only about sharing the publications or data, but also the source, the methodologies, and the educational resources. That's the ultimate goal where we are heading to. And also within EPOS, we are trying to make these resources available and share, and mostly focusing, of course, in our case, on data and potentially software in the future to share and allow easy access and findability of all the resources which were funded by public funds. Open science has benefits and barriers. Focusing on the benefits first, it will give easier and timely access to data and scientific products. It allows verifiability because the data are shared and it's possible to reuse them, which means you can reproduce the research or the methods applied and verify again. Of course, it's efficient use of research resources because then you see whatever has been done already in the past. You can get the data, apply your methodology, for example, and then continue with the work following the previous methodologies or start building on top what has been already done. And of course, it allows access to open methodologies and algorithms. The barriers which are listed here are mostly related to different standards and vocabularies. That's especially across communities, that this might be an obstacle because different communities are using different libraries, different keywords. Another obstacle might be the fragmentation of the data, because to make them shareable, it requires some work, harmonization and unification of the data, for example. Another barrier might be difficulty to communicate between the scientists and IT experts, which are providing the tools how to share the data or methodologies with public. And of course, managing of data or any open sources or resources, it requires overhead to make them fair. There might be also intellectual property rights issues, at least perceived ones. Again, the thinking behind is whatever has been funded by public funds should be made available for the public again. I'm not saying immediately, it just can be an embargo period which allow the PIs to conclude and publish the results, but at the end, eventually, all data should be made publicly available. Of course, there might be also legal and ethical issues connected to sharing the data, but that can be also covered by having the proper policy attached to the data and licenses. So it just again requires a bit more work. All the resources we are talking about should be eventually made fair. Now we are talking mostly about data. So with that regard, we are talking about having the data findable, accessible, iterable, and reusable, and potentially even machine reusable or readable. So not only humans can find the data, but the machines can get the data and process them. The research data management in EPOS is a bottom-up approach. So we have scientific communities, which we call them TCS, the thematic core services, and they are basically the founding of EPOS and of the all data provision. And actually, the whole process started from that the communities were discussing that we want to build an infrastructure which provides access to our data. And this is done thanks to collaboration among scientific, IT people, and governance. And this is kind of the recipe for open science within our community. Engagement of the communities is important and has been crucial to harmonizing the data, the processes, and standards to create the infrastructure which is scientifically relevant for the reference communities. So the mission of EPOS is to establish a sustainable and long-term access infrastructure which is integrating diverse European research infrastructures under a common federated framework. So we're building pan-European infrastructure, allowing access to already published data. Here is the EPOS timeline. You see it haven't started overnight. It goes back all the way to 1997 to the conception phase. Then was a preparatory phase starting in 2010. And finally, in 2015, we had the implementation phase where we start developing the system, the architecture, designing the system, how it should work. And then in 2018, EPOS ERIC was recognized as an ESFRI landmark and was also the EPOS ERIC as a European Research Infrastructure Consortium has been established in 2020. In 2023, at EGU in Vienna, we started the operational phase and we launched the EPOS data portal as you see now. Still, it's being improved. New assets or services are being added pretty much continuously, let's say quarterly. And all behind, we have the long-term sustainability plan. So it's not an infrastructure which it's supported purely by projects, but now we have EPOS ERIC as a European Research Infrastructure Consortium, as a legal entity, which is recognized in all EU member states, resides, and the office resides in Rome. And the principal task of this ERIC is to establish and operate a research infrastructure. On the right-hand side, you see the current members or observers, and also countries which are included in the integration plan, but not yet members of the EPOS ERIC. The EPOS data portal provides currently discovery, visualization, and data retrieval. We have about 285 services right now, and about 180 weekly visitors. The numbers about the amount of data and data provided is changing continuously, so you don't need to pay attention to that. Just giving you an impression what we are actually dealing with. An important thing is that the whole system is made as a federated system, and it means that we do not collect data to one central place. We are connecting to individual data and service providers on the fly as the user is browsing through the portal and requesting the data and plotting them online. This federated approach has advantages and disadvantages. The advantage is that you will always have the data as soon as they are released by the service provider. So in some case, it might be with really short delay, hours or days. So that's a big advantage. The disadvantage is that because it's federated system, it relies on all the connections in between the servers. So if the connection is down, it means that you will not get particular data at that time. But also we are running a monitoring system, which is continuously checking every 15 minutes the availability of all the services we have integrated. And the status is also highlighted for each service, so the user can see what the issue might be in case the data is not available. Even EPOS is built as European initiative and covering mostly European area. You see the users are actually distributed worldwide. The statistics below shows that we have, yes, about 180 weekly visitors at the portal. The EPOS delivery framework, I would like to just quickly explain how it actually works. So it starts at the national research infrastructures and data centers. Those are the core of the EPOS system because they are providing the data and sharing the data and providing the services which allows to be connected to EPOS. These national research infrastructure and data centers are aggregated within specific thematic core services or thematic communities. We have 10 of them, as you see in the plot. So depending on the nature of the data center join the specific community and then follows the instructions within the community, including the quality checks, the quality assurance, and so on. Then we have this interoperability layer, which ensures communication between the thematic core services and the central system. So the central system consists of several layers. I will explain in a bit into more details a bit later. But you see in the white circle, we have the data portal. So that's what we will be dealing with today. And this portal allows access to the data to users, which might be scientists, IT experts, governments, or general public even. So anyone who is interested in getting the data. Here we have the 10 thematic core services. I'll just quickly read through it. We have data from seismology, from nearfall observatories, from GNSS data and products, from volcano observations. We have satellite data, mostly in INSAR data now. Geomagnetic observations, anthropogenic hazard, geological information modeling, data from multi-scale laboratories, and tsunami data and services. The technical architecture, again, is a similar view of what I've shown earlier. It starts at the thematic core services at the bottom, who are actually data and service providers, go through an interoperability layer to the ICSC, which means the integrated core services, where we do collect all the metadata, all the information, where the actual data is, and having all the connections. And then on top of it is the GUI, the graphical user interface, which allows you to browse through the assets, find them, plot them, visualize, and download the data. The light blue color shows the ICSD, the distributed services, which we are about to connect later. And those might be visualization tools or specific high-performing computers or high throughput computers, any additional, let's say, third-party services which might be connected to the system. The GUI is just, let's say, one of the clients of the central system. The central system is based on an API, so the graphical user interface connects through an API and gets the data for the user. At the same time, the GUI is just the tip of the iceberg, what you see, but a lot of work is actually hidden and invisible to users, and it encompasses all the components I mentioned earlier. So the portal we are building is aiming to be truly fair. I cannot say is right now truly fair, but we are aiming for that. And we have high engagement of the thematic communities. We have regular meetings, like quarterly meetings, understanding what are the potential new services or also improving the system itself. And today you will learn how to navigate through the portal and how to use it. This is just one illustration, what might be as the third-party component connected to the system later. We actually have a pilot implementation. This is an interface, like actually the Jupyter Hub, where you can have a Jupyter notebook and do the data processing. Let's say finding data at EPOS data portal, then forwarding them to the Jupyter Hub, and then processing them within the Jupyter notebook. So that was all from my side. I will now give floor to Harald to give a live demonstration of the portal.
Thank you, Jan. I'm Harald, by the way, from EPOS. You will be prompted with this dialog first. So here you can choose to leave your name and email for subscribing to newsletters to know about events such as these. And Jan will later talk about a guided tour. And then you can press do not show this again and store it in cache, or you can press continue to portal or just exit out like this. So we start with the data pane on the left side. Here mainly we have all our data and the 285 services, as Jan mentioned. Within here, if you press this one, you have a list of all these services. And then you have 10 different scientific domains. You have seismology, near-fault observatories, you have GNSS, volcano, satellite, geomagnetics, anthropogenic hazards, geological information modeling, and multi-scale laboratories and tsunamis. I will not say very much about facilities, that's a new feature, but it will be lab-oriented, and I will be more about this later. Okay, so still within this pane here, you can search for specific data sets and keywords up here in free text search. Then within filters, you can narrow down the amounts of services. So either you can do it by coordinates, have a spatial limitation there, or drawing a bounding box on the map itself, or you can choose geolocation and select the country you want to explore. Then you have a temporal filter here, which works globally. You can set in the lower and higher limits, or you can specify month, week, or day. Here we have data and service providers, which are currently 494. You can specify only to see data from one provider or more if you want. And then the different ways of visualizing. Either you can press map, table, or graph. So, and also within the service, you have advanced search filters. So those may vary depending on the service. But here you can specify further, specifically for the service, what you want to move on to. And then you can press the download button and see what kind of data that is here. And you can press the download button here or copy URL to get the direct endpoint. So to select the service, you can either press it by the text here or choose it as your favorites. And when you have chosen it as your favorite, it will appear here. And then here you can orient or deselect them as you wish. Yes, so those are the main features for the data. If we move over here, you have a location search, and then you have a plus and minus button to zoom in or out. And then you have a layer or legend tool where you can control your base map. Or when you have chosen certain layers, you can choose opacity or change icon sizes and such later on. Then we have the table view here, if the service is displayed there, and then you have the graph view here as well. Jan will tell more about the menu elements later. So now I'll give a quick demonstration from Sicily. Then I type here and it suggests to me Sicily, Italy, and zooms to the location. So if I want to narrow down the results, I use the bounding box around Mount Etna, which is an interesting volcano to me. Then I'm trying to find what kind of data do I want to explore here. So the first that comes into mind is geodetic or satellite data. Let's try the line of sight displacement time series. Then I will load only the tiles that are touching this box here. And then we see a bunch of colors. And to know what the colors represent, we go here into the layer and legend control tool. And then here's the legend. So this one says more than 2 centimeters away from the satellite is apparently down. And the purple here is more than 2 centimeters towards the satellite, indicating uplift, and the other one subsidence. So as for what we see here, it seems like there's subsidence in the right bank of the volcano, and it's uplift in the left. We can further go in here and specify. You can see how many layers there are in total. So here we see 5 results, and then we can toggle all of them off or specify just one. Okay, this one is up here. Let's see, not this one. Okay, so then we have one here, and it will say which period of time here. Some start of the measurement and end of the measurement. So about the 7-year period, a little bit more than that for this one, and satellite platform, descending, orbit track number. Yes, so we have some information here. You can also go in and specify to download just this specific tile that is showing right now. I can further customize here what you want to explore as well. Okay, so let's go into volcano observations. And here I find the earthquakes that are specific for this particular system. And if I go down here, I can modify quite a few parameters. These are the default ones, and they're set to quite low maximum and minimum magnitude. So let's say that I set the threshold to 3 to only get the strongest earthquakes, and then override a catalog, which is default, just a short period of time in 2018. So let's say I set it to the same as the INSAR roughly. It only goes to 2020. So let's set the upper limit to 2021 to have the whole year. And then we have starting from 2016 until then, press apply. And then only the strongest earthquakes for the 4-year period, 5-year period is there. Then I will lastly go to GNSS stations and products to see if I can correlate some of the INSAR data with GNSS movement. So the S here is for station. If I press the point marker here, it will usually be possible to plot this in graph view, but another option is to open a URL externally. And then you have the east movement, north, if you're interested in plate tectonic movement, or you have the up component, which is more interesting if you want to look at a subsidence or uplift, mainly on temperature or maybe on precipitation. So for this particular event, let's see, 2016 to 2020, then it seems to be uplift in this period. These bars here indicate an adjustment or some kind of calibration event. But apart from that, it seems like there has been a slight uplift. Okay, so, and then we see the location of the station and correlate it a little bit with the INSAR. It does seems to, like the green here is 0, and it is on average about 0, or it's not more than 2 centimeters of uplift at least during that 4-year period. So yeah, that was my demonstration, and soon good luck with your hands-on training. Thank you.
Hello again. Now it's 10 past 11, so let's resume with the meeting. As I said, you can continue working on the use cases if you want. Please submit a response once you are finished. I will go now through the hands-on part and explain how possibly the task could be completed. So I'm switching now to the form. So I will go through the individual tasks step by step. So the first was to deal with earthquakes and saying to use the Groningen area. So I will switch to the portal and then search for Groningen here. It brings me to Groningen. Then instruction was telling it I should zoom out a bit and then make a spatial selection box. So I will click this spatial selection filter button. I will just draw a rectangle around Groningen like this. Then the instructions were asking to go to use the free text search. So we'll copy paste the modern earthquakes term and use the free text search in the portal. So I'll paste it here and hit enter. Now it's filtering the list of services with the phrase I was asking, which should appear either in title, description, or just keywords. So if I open seismology, I see 3 services, and there's parameters of modern earthquakes since 1998. So I'll put it to my favorites, clicking the star. If you are interested, you can of course explore the details about the service description, which is available under the small I. We haven't explained it, but there are details about the service, the data providers, and the service details, and how to access directly the service if you want. Now, since there are not big earthquakes in the area, I need to modify the filter. So I expand the menu for the filter itself, scroll down, and I see the minimum magnitude is set to 5, and obviously there are no earthquakes with magnitude 5. So I'll set it to 2 instead, as indicated in the use case, and click apply. So now a new request is made, and I'm getting earthquakes within this area larger than magnitude 2. Then the first question is, when did the largest earthquake occur in the Groningen gas field? So if I go here, I can open the table, and then in the table view, I can sort by different attributes by clicking on the label heading. So I will click on the magnitude twice, and it gives me sorting the earthquakes by magnitude. The largest was 3.7, and that occurred on 16th of August 2012. So yes, that was the second one. The second question was whether you managed to download the list of earthquakes. Here, I've seen in the chat there were several issues with that. There are actually two options here. Either you can download the list of all the records after applying the filters by clicking the export data button in the table view, but this will give you only data visible in the table. And also, of course, applying the filters here. So that is just a subset. But if you want to get the full data, you need to go to the download button, as was introduced earlier by Harald. And here we have different formats. You can also download the text, the XML or JSON, or the GeoJSON, which is the converted version done by the central system. And this one is used for plotting the markers in a map. So if I click on the button for download the text, I got this citation. I can copy the citation to my clipboard and close. And as you have noticed in the background, the download already started, and I got the file downloaded here. So if I open it, I have the text file, and I can work with that. So that was for the earthquakes. We'll go further. I'll just switch to the second task. This is about GNSS. So I will use again the free text search. So I first need to clear the previous one. So I delete the modern earthquakes term. Now I type stations, hit enter, and again it limits the services. Now in total I have 11 services related to stations. I navigate to GNSS and then GNSS station with products. I will add it directly to my favorites. Now it's connecting to Portugal and getting the stations. Currently, there's actually just one station visible in this area. If you want to get rid of the spatial selection box, you can disable it here to have better overview and better visibility. For the stations, also you can customize the symbol if you want, or you just even make it larger. Yeah, so now the task was to investigate the movement between 2016 and 2018. So if I click on the station, okay. Now something strange happening. Maybe I will need to move the station to the top. Yes, now I can interact with the station. And here I have the link to the image. So I click on that image And then I want to indicate or explore the period between 2016 and 18. And I see there is a very slight subsidence happening here. It's probably not even those 10 millimeters, but that was because we were using slightly different data earlier. And there's also the trend which you should add to this subsidence to get the total value. So it should be definitely subsidence for this question. I think I can move to the next. Then we had the last task, or last question, whether the geodetic motion observed by GNSS station between 2016 and 18 was accompanied by earthquakes. Now I need to go back and then explore whether there were any earthquakes. Well, around the station itself, depends how large area the subsidence was affecting, but now we are focusing around the station to compare the subsidence from the station, and we see only one earthquake here, but this one was happening in 2023, so it's quite recent, but nothing in the period between 2016-18. If I sort the earthquakes by time here, I can also navigate to see whether there was anything happening in the period 16-18. There were some events, but that's comparable to the background seismicity happening in other years as well. So the answer, or the expected answer, was actually no in this case.